on some special right triangles here. Now there are two special right triangles. There's a 45, 45, 90 and a 30, 60, 90. Now they're literally named after their angles. So for example, the 45, 45, 90 has angles that are 45 degrees, and 90 degrees. So if you ever see these angles, that's a big sign of your pattern. Now, each one of these triangles has a special pattern. Now, the 45, 45, 90's pattern is x on the one side, x on the other, and x square roots of 2. The 30, 60, 90 is x, 2x on the hypotenuse, and x square roots of 3 on the leg. Now, you're going to want to have these little patterns memorized because they're going to make your life a lot easier when you're solving problems. All right, so on our first example here, I want to show you. This is the 45, 45, 90. I think it's easier if you put the pattern on the triangle. You could say the pattern is x, x, x square roots of 2. Now, if x is on the same side as the 5, that means x equals 5. That means the other side is 5, and the other side is 5 as the x in front of the square root of 2. Now, you can type this in and get a decimal, but I wouldn't recommend it. 5 square roots of 2 is a perfectly acceptable answer. So this just shows us how easy I know that if I know one side, I can instantly know all three. The only time it gets a little bit trickier is if they give me the hypotenuse, because when I put my pattern on x, x, x square roots of 2, they're telling me that 10 is the x square roots of 2. So to figure out what x, you have to do a little equation here. So I'm going to say 10 equals x square roots of 2. To get the x by itself, I'm going to divide each side by the square root of 2. Those will cancel, so I have x equals 10 divided by the square root of 2. Now you don't want to turn that into a decimal, but you also can't leave the square root on the bottom, so go ahead and rationalize the denominator. And what that means is multiply the top and the bottom by the same number. So when I take the square root of 2 and the square root of 2, it gives me 2. 10 times the square root of 2 gives me 10 root 2. And you think you're done, but you're not, because can't 10 over 2 reduce the number 5? So therefore the value of x is 5 square roots of 2. So that took a little long, but now that tells me that this side, this leg is 5 square roots of 2, but also this leg is 5 square roots of 2 also. So that's our 45, 45, 90 triangle. All right, our 30, 60, 90, we're going to start the same way. You're going to start by putting the pattern. The short side is x. Now the short side is always going to be across from the 30. The hypotenuse is 2x. And the leg is x square roots of 3. So if I wanted to figure out what the value of x is 2x is 12. If 2x is 12, doesn't that mean x is 6? So I know the short side is 6 and that the leg is 6 square roots of 3. The only time it gets a little harder is if they give you that radical side. So let me start by doing this pattern again. Short side is x, and I know that because it's across from the 30. Hypotenuse is 2x. And this is x square roots of 3. So let me show you how to reduce that radical again. 9 equals x square roots of 3. Divide each side by the square root of 3. Therefore, x equals 9 over root 3. You're not allowed to leave that like this. You have to multiply by whatever radical's in the bottom. So square root of 3, square root of 3. Therefore, on the bottom is 9 square, on the top, sorry, is 9 square roots of 3, and the bottom is 3, because the square root of 3 and the square root of 3 just make a regular 3. Look at this number, 9 over 3. That does reduce. So 9 over 3 is just 3 square roots of 3. Therefore, 3 square roots of 3 is our value of x. All right, that means I can come over to the short side and say that is 3 square roots of 3. The hypotenuse is twice that. Twice that number is 6 square roots of 3. Now I have all 3 sides of my triangle that I couldn't have figured out any other way. So hope that helped.